So hi. Yeah, maybe you know it or you don't, but like getting this sort of a conference together takes a program committee, and they then have to find a program, and most important, a keynote. And then we go about, well, who should we ask, right? Keynote is like invitation. So then you go to the list, and then there's people that probably already had, like Linus was at NLUUG already, so we can't ask him. And so there's other people that probably you will not get, like Vint Cerf or so. We tried, but yeah, well, he was kind of busy. And then you go, hey, but those are famous names. But what if we look at that differently? What's new technology, and who can tell about new stuff? Who can tell about new stuff that's coming and that's currently emerging? And then you have, well, what's new? Cloud. Well, cloud we know, but multi-cloud and what can we do with it, and stuff that's on the horizon, like secure transactions, blockchain, all those kind of buzzwords come around. And then, well, then a name got up in my head of someone I've known for like 17 odd years. Met him at an early Lisa. I kind of know it. It was in San Diego, but at that time he was working at VMware with new technologies. Well, at that time virtualization was the hot thing, and he had this great idea on how to build it out. And I thought, well, he could do a keynote. So we got talking some more, and yeah, well, it kind of emerged. So we brought in Yani Arrasjid from, at the moment, Virtustream. Well, he did every great job on earth, I think, and he has this vision on cloud, how we progress, what's the next steps, how we integrate stuff, how we get that actual buzzword to deliver business value, and that's what everything is about. Well, the business value is also a buzzword, but John can tell you how that actually comes together and will come together in the next few years. So, without further ado, John, take the stage.
I will be reaching over to hit the button to move the slides along a little bit. I didn't bring a remote. I figured with my slides, I'm not here to give you a list of things. I want to talk to you about some of the stories that I've come to be involved in around cloud, and in particular mission critical workloads in the cloud. I have a quick question. How many people here are using a system like SAP? Yes? Okay. Are you, for the others, are you using complex systems like that for ERP, CRM, monolithic applications, or are you working more with containers? These are all things that are going into the cloud, and it's been evolving over a number of years, and I see a number of things through some of the POCs and some of the work projects I've done with partners and with customers, including in all the countries in Europe and around the world, and we're seeing a large evolution in what it means to be mission critical and what it means to have an underlying infrastructure to support those mission critical workloads. So the topic that I have today is basically the cloud evolution and bringing mission critical workloads to the cloud. I do have to give a disclaimer. I work at Virtustream, which is part of the Dell family of companies. My goal here is not to advertise specific technologies, but I have some examples. My goal here is to give you conceptual and logical design concepts to help you with understanding where I'm going. The items that I cover in here are related to the research that my team is doing at Virtustream in both the Office of the CTO as well as the Ecosystems Engineering team. So I'm going to start off just with a quick set of basic definitions that, from my perspective, I see as the evolution and where we've gotten to today. So first off, let me give you my background. Virtustream, I'm a cloud architect, an IT architect. I'm fortunate to have been one of the first VCGXs going through the process of not just evolving the program, but also mentoring people around the world on the concepts within this area. I've also worked at a number of other companies, starting out with AT&T in the early days, working in the Unix systems group, working on the C language issue 5 meaning the 5.0 release. It's going back a ways to about 1988, and that's where my early start was. But over time, I've evolved and worked in the mainframe industry, my first exposure to virtualization, working on Sun Microsystems, their old Motorola-based systems, at Amdahl to develop graphical interfaces for doing testing of the mainframe systems. I didn't work on the mainframe, but we dealt with a lot of the virtualization within there. Kubota Graphics and 3D Effects listed up there, you may know. I worked in the graphics industry for a little bit. I worked at Roxio. They had an office in Würselen, close to Aachen, over in Germany. I had some team members there in the US. I worked in the EDA industry, had my own company, WebNexus. But I've spent the last 16 years working within a family of companies, and it's evolved. But I started out at VMware back in 2003, where we focused on several things that have become revolutionary. The concept of virtualizing compute at the Intel or the AMD platform. Today, VMware actually now has ESX running on Raspberry Pis or ARM processors, which I find very interesting, especially in terms of industrial IoT. But I moved on to Dell EMC, worked in the CTO's office on some research that I'm going to be talking a little bit about here, which I carried over to Virtustream for the cloud effort as well. A couple of other things. I want to give you my background because I don't know how many people here have I met before? Do you guys know, have you guys followed me at all? I'm just kind of curious. I figure there's for a lot of you, maybe this is the first time you've gotten to meet me. These are some of the books that I've worked on. The first three were tied to working on the virtualization and the cloud revolution areas, talking about specifically VMware, but as a VCGX, I'm not focused just on the physical technology or the physical design areas. Looking at conceptual architectures to get an understanding of what somebody needs to implement in their environment, moving to a logical design, which has a longer lifetime, and then finally getting into the physical design area, where we're doing the technology, the configurations, the vendors, the actual products, and getting to that final stage where you have a limited time. There's a life cycle or a lifetime of a specific technology once it's released. So I always try to focus on that conceptual and the logical design first. In here, we've covered a number of different things, including the certification. And the last book was specifically around methodology for infrastructure design, and some of the examples are on virtualization and on cloud. And then the last few, I'm just going to advance pretty quick here. I get involved in a lot of different things based on meeting people like those in the audience here. Some of them have introduced me. I got started with the Usenix Association going back quite a long time. As Rudy was saying, we've known each other for 17 or maybe even longer years. There's another speaker here, Mike C., who's speaking later on today. The three of us have known each other for quite some time, and I think it's a great opportunity for us to actually talk to you guys here. But I was on the Usenix Association Board of Directors, worked as the vice president for a little bit, and basically looking at how we can advance from their large installation sysadmin conference called LISA, how can we advance the art of infrastructure design, IT operations, as well as some of the developers that are working within that environment. But I also like working with outside groups. I'm a big proponent of, yes, I'm in the technology area, but what do we all do besides technology? We all have different things that we're interested in doing. As you can see here, I'm very interested. I loved Jacques Cousteau. I watched his work early on, and I had an opportunity to get to work with his son, Jean-Michel Cousteau, on some fundraising for a project that he was doing for education and working with museums and aquariums to teach and have live interactions while he's out at the boat. Yes, the technology exists today. Back when his father was doing this, it didn't exist, and that's one of the things that I do want to talk about. I bring this up because there are some major revolutions going on in both the programming paradigms and the technologies for that, as well as the different types of things related to AI, Internet of Things, and blockchain specifically, not for cryptocurrency, but for provenance of data. How do we make sure that the data is accurate? Is it coming from the right locations? And so on. So I'm going to give you 3 examples from the research that I've been doing, and a little bit of a tidbit of some of the presentation work that I've done this year around industrial IoT. And if you need to reach me, my avatar is because I love playing music. I've got a little injury on my hand from being in Barcelona last week, so I'm a little bit out of it right now. But that's one of the areas that I'm also excited in. And I do have a question here. How many people here are musicians? Any? Do we have any here? We have a few? Cool. So maybe one of these days we can do a little jam. I do have another. I play guitar and I play ukulele, so it's a little mix there. I did have another question because this region of the world is known for something that I really love to work on, and that's blacksmithing. So I don't know, do we have any blacksmiths in the audience? We do. Excellent. I do want to talk to you later on. But this is something that I've done for a number of years. My father-in-law got started in blacksmithing after he retired from running a Sears department store. It was a small store, but he was a manager of that store. He started doing blacksmithing and found that this art is coming back. It's, you know, there's another evolution and revolution coming together, and it's not just in the technology space, it's in some of the other areas. But I thought I'd give you a little perspective that I'm not just a tech guy. I like to do other things as well, and you'll find that I'm very much an extrovert, and I love talking. So if I talk too much, let me know. So I kept the agenda simple, to the point. There's a lot more detail that I'm going through, but the idea is how have we gotten to today in the tech industry, in infrastructure, and in the type of workloads that we're dealing with? And where do I see things going in the next stage? And I'm not talking about decades, I'm talking about within the next few months or the next maybe 1 to 2 years. This is happening today. I'll give you the examples. And I have some predictions on where I see this going based on my work with a number of different customers. So, and I have to apologize. Is there a remote by any chance? I guess that's the one thing I love. That's okay. If you guys don't mind me stepping in front. So I'm gonna do a quick build out here, one at a time. First off, when I look at cloud, there's the on-premise aspect, there's the off-premise aspect, there's governance around that, there's different regulatory compliance based on the type of workloads. But a lot of this got started with virtualization. We started adding on automation, we added on technologies to help with creating a self-healing environment. But in many cases, change management may introduce some aspects that you have to think about. So for example, with vMotion technology, are you guys familiar with that? Live migrations of workloads from one system to another. That started originally within a data center. Now you can do it across continents. So there's a new technology that VMware, this is just one company, I'm giving you examples of what I'm familiar with, but there are other open source technologies that are moving this space as well. But basically that gives you the ability to say, I've got a workload in California. I live in California. We're having these major wildfires right now. What if we need to evacuate workloads? And because the state is being so affected by the fires, we need to move it to a geographically distant location. And to do that, you can do cold migrations. Those are very easy, but there's downtime. And so with some of these new technologies, like with HCX, that's the name of one of the VMware technologies, they have that ability to go from, for example, Netherlands to Australia to the US to Antarctica if you have the bandwidth for it. But in any of these cases, just because you can do something doesn't mean that you should. So here's the example. What if you're dealing with highly regulated information? My personal information, my financial information, I want that protected. And so that's something that we always have to think about as we go forward. How can we use the technologies that we have for good and try to avoid the bad that may come out? But basically, virtualization brought about the concept of software-defined data centers and new types of software-defined elements like networking and storage and things like that. Now, in the beginning, we had the cloud on-premise based on virtualization. But a lot of service providers realize, hey, we can monetize on this. I happen to be part of an ISP that got started in the early days before we had virtualization and all of that, but we had a concept of cloud. Cloud is actually a marketing term, and I remember when this was getting evolved, why did they call it? I used X terminals back in the day. I used a TN3270 on a mainframe. They're not exactly cloud, but they actually were the precursors to cloud. And in the last 10 years, we've seen technologies advance in so many different areas. We have the ability to do new things for the greater good for mankind. So I'm hoping that you all have that positive aspect in thinking about how can we do things better, not just in our daily lives with our work, but also in our personal lives and our social lives. I'm a big proponent of that. I do live in California, so if that explains it. So we had the off-premise cloud. We also had the concept of cloud bursting or a hybrid cloud environment. Cloud bursting, it exists, but I don't see that as the main use case for a hybrid cloud. I see a lot of the evolution happening on how do we put the data or the workloads in the right place. And today with governance, it's more about moving the compute or to the location where the data is when you have highly regulated data. So for example, in the EU, if I was here in Utrecht and I basically wanted to access data in another region, I have to follow all those regulatory compliance guidelines. We have to think about that from that hybrid model. And what we found is as more cloud providers started advancing their work and specializing in certain areas to create, for example, a healthcare cloud or a financial cloud, they had different governance to drive that and different types of math paradigms around the algorithms that were used to build the workloads that they've created. But it didn't just end there. We also had very specialized hybrid situations. So in the healthcare industry, there are now, and I can speak for the US, I can't necessarily speak for all the other regions of the world, but in the US, we've basically started to see that both the pharmaceutical industry and the healthcare industry are looking at how to be more effective, where a doctor can work in their special office, they could go, their own personal office, they could go to the hospital, they could go to another location and get access to an interface to be able to view patient results in a way that actually protected the patient data and protected the locality of that data. But the one thing that I'm seeing now with this is the need for a multi-cloud solution, and that's where we need to start thinking about this dedicated or a specialized connection across all the different cloud providers who may have different interfaces, different functionality. How do we make sure that if a workload from one cloud provider moved to another cloud provider will get the same set of SLAs and the same set of functionality? So different cloud vendors, and you can name any one of them, they're all looking at multi-cloud as one of the next steps. So IBM coined a term many, many years ago, maybe it was decades, called co-opetition. And what we're finding is that competing companies are now having to work together to support the customers. And in some cases, there's a mix of open source and commercial technologies. I have been working in the commercial industry for a while, so I do know a lot about VMware and so on. But there are also a lot of things that we're seeing becoming more and more prevalent. Fortunately, there's some very good talks that are happening today that I'm planning on attending around things like Kubernetes and containers, because these are things that are fundamental for a lot of the IoT, the Internet of Things, and how they actually develop programs, microservices, AI workloads that are based on that, and so on. The other thing that is important is thinking about which cloud provider for the type of workload you have. So if you have a mission-critical workload, will you put that in the cloud? And it's going to be based on governance. It's going to be based on the functionality. Here I'm calling out a couple of these. SLAs are very important. At my company, we focus more on mission critical than on sandbox. So when people ask me, how do you compare with, and I won't name names, but whatever vendor you want to pick, I have to say, well, we can compare as a cloud provider, but the type of workloads that we support may not be the same as this vendor or that vendor. So it's based on those workloads, and some of them, just because something may seem cheaper, doesn't necessarily mean that it really is. What is the total cost of ownership, and what is your return on investment? Assured performance is very important. If you are dealing with mission-critical workloads and you're in the retail space or online, for example, downtime of minutes could actually cost millions of dollars. Think if Amazon were to be down from their commercial side for just a minute or two, how much revenue would be delayed or lost because of that? So these are things we have to think about. Integrated backups, high security, regulatory compliance, and geo-compliance requirements are becoming more and more important. They've always been important, but now that we have the ability to move workloads vast distances live, we have to make sure that we got the right governance to ensure that we don't run into those issues that when you cross certain data across boundaries will cause. We're using a technology from VMware called NSX. Has anyone heard of NSX here? Yes, a few people? So they've added some technology for policy engines to prevent transit across geographic boundaries. You have to implement it the right way, but it's something that not just VMware, others are doing as well. I can't name all of them. I'm sure there are some in the open source space as well, but a lot of the commercial vendors have the ability to do certain things because of partnerships and obviously because of the revenue that they use to make further investments within their research arm. Now I'm going to build this out. There's 6 elements that I've heard from enterprises as being very critical. And I'm going to assume that you have similar aspects of this. Performance is going to be based on the type of application. Is performance absolutely critical, or is it a batch job? You can wait, hours or a day. Think about AI workloads. Training of a deep learning workload could take hours or days on these very high-end processors, GPUs, TPUs, video processing units, and so on. We also have to think about availability. If it's mission critical, how do we ensure that it continues to operate? We've got the security and compliance that I mentioned earlier. There's scalability. There's a customer that I talked to last week who has a monolithic application. It's been running great for the last 30 years. Yes, it's been refreshed. It's still running on Spark systems, and it's doing everything that they need today, but it won't scale for the future. As they add more customers, as they add more patients and hospital systems and medical care systems, they have to think about changing in a way that can support that growth so they can increase their business. And what they're looking at doing is going from a traditional waterfall methodology to an agile methodology. They're going from a monolithic application that's based on Spark systems, which I grew up on, Sun Microsystems, right? But basically, they are now moving to microservices. But then you run into certain issues that you might call political or personal opinion, where people are saying, so this person I'm talking to is a CTO, he's talking to some of the leadership that are saying, well, it's been working for 30 years, why should we change anything? And it's like, if you don't stay current, yeah, some things can continue to run, but do you want to stay where you are in your business? Or do you want to increase the opportunities, increase the type of ability you can have for any of your customers? I do want to get a quick survey here. Usually at a conference like this, we see more in the industry side than in the academic side. But I'm kind of curious, do we have representation from academic side as well in here? Yeah, we do? Okay, good. So one of the things that we found is marrying the concept of an industry working with education or with academia has been very powerful. I'm doing work on some of my research with somebody who is a PhD candidate at the University of Ireland in Cork, and he's working on AI and IoT, and it's working out to be very good. I mean, Rudy and I were talking about some concepts of how do we get more collaboration and how do we make sure that we ensure that we don't cross IP boundaries of, if I work at one company, somebody works at another company, can we propose ideas together jointly? You can do that. It's definitely something that can be done, but you have to work with your legal teams to make sure you do the right thing. You have to think about patent concepts. For those that are out here, if you have an idea that you don't see others doing, a process or a particular technology space where you can develop a concept and patent that, that gives you some recognition. It gives you some ability to actually drive the ball forward, and it helps the industry. I'm not as big on patents for one key reason. I think the lifetime of a patent is so long, it can stifle innovation. But there also has to be protection, and that's one thing that I kind of have this, I'm sitting on the fence of, the pros and the cons, and that's something we have to think about. The economics are very important. The management services, do you just have management tools, or do you also have a group that focuses on IT and OT? IT for information technology, we all know about. OT is not just about the people who are dealing with applications, they're dealing with the life of the company. So IT, we want to make sure we reduce risk, we make sure we have availability and all of that, we make sure performance is going on. But the people that are in the OT space are very focused on the life of the company that they're working at. And it's a marriage of the two, or not necessarily a marriage, a relationship, a working relationship, that I would recommend that if you are working with an OT group, definitely get to understand their perspective. Because we all have different perspectives in the roles that we work on. When I just did system administration, before I did architecture design, I didn't always understand the reasons why certain things were done. And as I've gotten older and I've learned and I've gotten some more experience, maybe I did one RM-R on root once in my life, and I was really surprised that the system ran for a while until I learned a little bit more about that. These are all things that we learn. We'll have positives and we'll have negatives, but we want to learn from those negatives to go forward, and that includes experimentation. I highly recommend innovation. In your environments, you may have support from management to innovate in certain areas, but even if they don't, you have the ability for your own self and for your career to think about things that you are interested in. I'm interested in IoT for many reasons. I have a Nest system at home. I have a number of other things for things. I mean, yeah, there's Big Brother, maybe there's a little bit of spying going on of what's going on in my house, but there's a convenience. How do we balance those things out? So when we look at all these different things, they can relate not just to the job that we do, but also to our personal lives. Out of curiosity, does anyone have like a Nest or an Amazon? I'm seeing a lot of nodding heads. And have you turned off certain aspects of monitoring? Yeah, I see some heads that are saying, I'm not going to risk this. I had to turn off on my iPhone the Siri system for constantly listening, because I was on a conference call, and then all of a sudden Siri started talking to me while I'm actually leading a discussion. That really bothered me. Anyways, you guys have maybe seen or heard of experiences like that. What I want to talk about now is some of the trends that I'm seeing and some of the new mission critical workloads. Before I get started, I couldn't get permission because of the timing, but there was a Gartner survey recently on emerging technologies. If you guys are interested, later on I can share the link for the site where you can get it. Gartner, you have to get special permission and all of that, and they need to review the docs and everything. But what they talked about was, if you look at a curve of where enterprises, companies are adopting new technologies, where are they? Are they at the early stages, and has the technology just gotten started, or has it evolved? How many people here work with blockchain? Any? Few? And for those that are working with blockchain, is it more cryptocurrency or secure ledger? Ledger? Yes. Any others? So there are technology changes that are happening now with things like blockchain, where it's not just about cryptocurrency. So secure ledger was always part of that, but now we're seeing with some of the newer technologies where you don't need high-end graphics processors or TPUs to actually deal with this. With cryptocurrency, it can cost you a lot of money to do those secure ledger transactions with blockchain. But when you're dealing with it for non-cryptocurrency, there's now technology out where you can get, instead of 10 transactions per second, 60 to 100,000 transactions per second on a CPU, not a GPU. And so these are some of the things that I'm seeing that is changing. That particular technology, it's SBFT, which is tied to Byzantine fault tolerance, to figure out how do we do distributed secure ledger. And this is where I'm seeing cloud providers also starting to get involved as this new technology breaks. The cost was very high for a cloud provider to say, oh yeah, we're going to offer you the ability to do ethereal, or Bitcoin type of transactions. But now there's opportunities to actually use this technology in other ways as well related to IoT and the whole stream of the data flow. So some new mission critical workloads. I found this diagram on Shutterstock. It's a great place to kind of get some ideas, but I had to do some modifications on it. What I want to do is kind of show what the future holds. So in here, I'm showing things like AI and deep learning for doing predictive modeling, creating inference engines. I'm seeing augmented reality. There was one conference I was at last year where they were presenting a lights out data center situation. So there's a data center that has some staff, very minimal staff. They're not the most senior people. And a situation comes up where they would have to normally fly somebody out to that particular location from another geographic location. But now with augmented reality, we have the ability to walk into a data center wearing these glasses where you can see what the person who's local, I may be in California, this person might be in Texas or here in Utrecht. That other person is my eyes and ears, but there's also additional data with augmented reality that can be layered on top of it. So if I walk into a data center, I know there's a problem. Think about this. If I walk into that data center and I immediately see that there's a rack system that's showing red or it's flashing or whatever color you like to have to warn you about something, I can now go closer to that system with that other person maybe being my visual aid. And because I've got expertise more than that individual, we can go to the chassis and start identifying ports on a system they're identified as red and have that person do the hands-on operations with an expert, not just on the phone or on a WebEx or or Skype or video conferencing. They're actually seeing what that individual says. They're about to unplug a cable and we can say, hey, wait, no, stop. These are the types of things that I'm seeing happening and the technology is developing. I see more on the commercial side than on the open source side, but the same thing is happening on that side. A lot is coming out of the academic research at universities around the world in this space. The other thing too that I would add on is machine learning versus deep learning. Machine learning is where we got started with rules and things like that were programmed in by humans. Deep learning is where we're getting to look at data in a way that we couldn't do as individual humans. What we can do now is, what are the anomalies? And based on that, this technology can start writing rules. So there's a number of them. I'm not an expert in all those areas. In my current role, I work on putting systems together, but I'm not doing all the dials except when I get a chance while we're going through some of the demos to actually do that. But anyways, two of the examples that I wanted to show here is in both the grid for energy. My house is 100% solar. I'm still connected to the grid. But basically what it means is, as I go into retirement, there's no more cost for power. I'm curious, how many people here are using alternative energy, either wind turbines or solar? Cool. Thank you guys, because this is what's going to help change the world in a number of areas. Lower pollution. And whether or not you believe in global warming, I do believe in it because I've seen the results of it. Whether it's man-made or not, I'm not going to argue that. But I do see that what we can do every day in our lives, both in the computer industry and also in our own personal lives to help. But in these areas, I've done some work with a particular company called Toshiba, and I'm going to give you an example of this, where they came to my team and a couple other teams in our family of companies and asked us, hey, we want to do this AI project. We're working with the government in Tokyo for the Olympics that are coming up in 2020. So we'd like you to help us with this AI project. And as we delve deeper and we help them with putting their algorithms in place into the cloud, we actually learned that they had a third-party company that was collecting data from these transportation groups. So in this case, it was taxi companies. The taxi company driver would have a cell phone. That was their sensor. And by providing information to the driver became the actuator. But this can be applied to autonomous cars or even semi-autonomous driving technologies. The other area that we found that they were working on was with systems around smart buildings and smart cities. I'm not sure how much your different companies are tied in this space, or if you've had that experience, but one of the examples was meeting with this company, meeting with one of the individuals, the employees, and we're walking to an elevator, and they did a facial recognition of the individual, and they also had the RFID on the badge to know, oh, this person's coming in at this time, they're heading to the elevator, and normally at this time, based on the last few months, we know they're going to go to floor 4. And so when the person comes in, it's already pushed for button 4. Yeah, it might be a mistake, sometimes that happens, but the thing is, it's ongoing learning. There might be some other things that could be added to actually help with more accuracy on that, but the same thing applied in that taxi system of, if you have to pick up a number of passengers, and in this particular case, taxi drivers in Tokyo can pick up to 8 passengers. Now, let's say I have a passenger in my car, I'm a taxi driver, and I see you right there, you're this far away from my taxi. Just because you're that close doesn't mean I can pick you up, because it might not make the SLAs of both you and the other passenger I have, or any other commitments. So this company is using AI to learn how people are using transportation, making sure that they can meet the SLAs. They have specific SLAs on pickup, drop-off locations, timing, and also they are looking at where people are going. So if they see that 100 people are taking a taxi to a shopping center, it's likely they're going to get picked up by a cab company. So therefore, they can actually predict to say, let's make sure that there are enough cabs in that area to actually support the return traffic. There's another thing that they're dealing with, and that is aging populations in the rural areas. The younger generations tend to go to the cities because there's more work, and if you're single, you have more opportunities. I'm in the country because I'm married and I have kids, and I don't need as much of that social interaction, although I love this kind of social interaction. It's a lot of fun. But this is one of the things that we're seeing is, as the technologies are evolving, they're helping us do more interesting things and smart things. But there is also the negative aspects. One of the negative aspects, I think it was Bolivia, where somebody used a drone to try to do an assassination. These are the negatives. I kind of wish that we had the ability to take Asimov's rules of robotics to say, how do we make sure that this doesn't happen? You can't just say, yes, we'll use the rules of robotics to prevent those things from happening, where we prevent people, computer systems from harming people. But we as individuals together can be a monitor to that. We can actually help to try to take a positive aspect and try to prevent negative. Although it's always in the perspective of the individual. So, if you've got one person's perspective on one side of a fence and one person's perspective on another, you may or may not be aligned. In some cases, there are going to be significant differences, and we have to work within that. But I see all of these as key things tied to the research that I'm doing and things that we're looking at as we develop our cloud technologies for mission-critical workloads. Now, what I'm showing here is kind of an example of what we see of multiple data centers, edge gateways, and Internet of Things devices. And what we're seeing is there are more and more devices coming forward. Anyone who says, yeah, we can keep on using IPv4 forever, they're dreaming something that's just a bad dream. Right now, we really need to think about going beyond NAT and PAT, because there is overhead. And if we can use that overhead for more work elements, it's going to be much better. But what I see here is, as we build out these connections, we're connecting the data centers, we're connecting the devices, and together, this is where we're seeing this industrial Internet of Things. And the reason why I say industrial is there are very strict guidelines for performance, for governance, for protection of data, confidential data of an employee or of a company. But what I'm seeing is it's becoming more and more of a large problem that we will have to face related to data, which is why a lot of companies are now looking at pushing the data closer to the edge, where you have an edge device, you have an edge gateway that could do either processing or gathering of data. And some of these gateways now are including accelerators like GPUs. And I expect that TPUs will happen. VPUs, video processing units, are also there. Specialized math that act as kind of like a coprocessor, specifically called accelerators, to accelerate specific mathematical functions. So I wanted to give a couple of examples here. I'm going to go into a little bit deeper dive on one of these, but we've got AI becoming more and more prevalent. And the cloud works very well because if you have to build out on premises, what is your cost of ownership? How many GPUs or other types of accelerators do you need to have on premises? We actually did a POC, the one I mentioned on transportation, where we used 2 NVIDIA T100s to help them with processing, and we actually were able to cut the processing time from 12 hours down to about 2 hours. And with further refinement, it could probably get faster. But when we first started putting these workloads in this environment, we found that instead of using the GPU, they were using the CPUs. And it's how they did the programming. And so we actually worked with them to get them to use the GPUs, and then we found it was single-threaded. Well, we got 2 GPUs, they're $8,000 each. We want to be effective in our processing and our total cost of ownership. So we worked with them to figure out, okay, why are you serializing it? And it's like, well, that's what we've learned from XYZ, you know, on the internet. So not everyone has a full group of data scientists. We may have people that are developing AI and IoT related stuff by pulling stuff off the net. You have to understand the workload and you have to understand the resources you have to be effective on that cost. How do you make sure that when you're doing the deployment, are you using it effectively? So these are programming 101 types of concepts. Make sure that your workloads will fit the type of resources you have. But what we found in that particular situation was they were getting maybe an improvement of a small amount. So they went from 12 hours to 11 or 10 hours by just using the CPUs that we provided because they were newer CPUs, they had more memory, more caching. But once they started using the algorithms in a way that were designed for the accelerators, that's when we saw the major improvement. And that's why it's a combination of IT working with OT. The OT people are the ones that are developing those AI type of systems. The other area is in genomics. In genomics, I'm not seeing companies in healthcare or in specifically for doing genetic related information around DNA, looking at figuring out how do you repair a problem within a particular DNA sequencing, what can be done. We have to be careful for many other reasons, but the one thing I wanted to focus on is they're not just using GPUs, now they're actually looking at FPGAs. So FPGAs require you to program in Verilog. You program it, you may reprogram it, but they're finding that that was the most efficient way. They got rid of the extra stuff that you have in a GPU and stayed focused only on the functionality they needed for the genetic engineering or the DNA sequencing. Cloud robotics is another area. How many people here have a car that has LiDAR so you can sense where you are in a lane? I mean, we have a Highlander hybrid, and in there, you know, it can detect, are you moving out of your lane, give you a warning. It can do other things that are getting closer to, you know, things that you need for autonomous systems for a car system. But what we're seeing is this concept of cloud robotics, where you have all the AI in the cloud. You can't just do everything in the cloud. You need to have some stuff that's closer to the actual device for safety reasons. Or maybe there's an issue with network connectivity. Even with 5G, you know, Rudy and I were talking about this, even with 5G networks coming, what happened when we got 4G and LTE? What happened when we got 3G? We always said, oh, this is the bandwidth, it's going to solve all the problems. And people didn't get smarter in how they coded. They didn't get smarter in how they handled data provenance and making sure that, look, if we can do processing closer to the device that's generating the data, it means it's less bandwidth, lower cost, more efficiency, and you can deal with real-time situations such as, oh, we know, so we've detected that the traffic has slowed down. Let's go back to the cloud and see if there's some other pathways we can take for routing differently. So these are some examples of the types of things that we're seeing in workloads. But there's also, and I'll do a full build out here, distributed secure ledger for the enterprise. So there's something that my team has worked on with the San Diego Supercomputer Center down in San Diego, California. And it's called Block Lab. It's a blockchain research laboratory, not for cryptocurrency, specifically for thinking about the use cases around secure ledger. And there's different types of blockchains. We looked at distributed ledgers for financial transactions. for use cases around other types of digital transactions. For example, in IoT, we might have a sensor on a heating system and a sensor on a cooling system. What if those pieces move into different locations? Right now, we're doing some research on that, on how do we make sure that proximity of those sensors don't change. And there are technologies that are out today that can actually identify if somebody's moved a particular sensor. And then smart contracts. How do we ensure that we not only can provide evidence that a transaction was made, some of them might be financial, not cryptocurrency, but financial transactions, or they might be other transactions. So in the space program, one of my friends works at SpaceX, and they are dealing with IoT greatly. You know who I'm talking about, Matt Simmons. And so a friend of ours, has been doing this for a number of years, working on the IT space, and he's talking about how many sensors they put in a rocket ship and how much they have on land and in the satellites. There was a presentation that Vince Cerf had a couple of years ago at a Usenix Lisa conference on the planetary internet and basically how do you deal with massive latency because of the very large distances that you might have. We're going to have to deal with that. But basically, the key focus here is on thinking about how to use secure ledger in your environment where you have a particular need for ensuring that the pathways, the ownership, the source, and the destinations are all clearly defined, and you have full traceability. You have all the evidence to show that if a problem happens, you can trace back on where the root cause might be. So the one example I give here is a technology that VMware has, I mentioned earlier, the Byzantine fault tolerance. And in there, that's where they're getting this major change in blockchain for secure ledger. So what I want to do next is talk about 3 example use cases. Transportation is one, security is another, and healthcare is a final one. Again, I'll do a quick full build out here. So in this particular case, this is tied to the work that I've done with Toshiba in Japan related to that transportation system. They are dealing with taxis first, but they're looking at extending it to other transportation systems. They have data that's collected. Right now, it's by these cell phone devices and certain other types of devices that are added to the cars, and then it gets collected. And the collection happens at the edge. And at the edge, we do some compute so that when we send the most important data up to the cloud, we ensure that we minimize the total amount of data because of the cost. So that's where you have to have the trade-off on deciding what is more important, getting all the data back to the core or the cloud, or doing processing at the edge and identifying some of the more important aspects that you do want to send back for the core training around AI workloads, for example. In this particular case, though, they have a sensor. Somebody says, hey, I'd like to actually go from this position to that position, identify the pickup and drop-off locations and time. There's some processing that happens, and then basically at the core, they're going to have additional data that's used to give us information or give the learning information on what is happening in the environment. Is it a rainy day? Is it snowing? Is it sunny? That may affect traffic. Is there any construction going on? Given that they're planning on the Olympics, they're thinking about how do we ensure that we don't run into some of the situations that has happened at past Olympics or other types of big events. And that is working with the government for sharing certain data about construction. Looking at all the different events that are happening in a region. With the Olympics, you have normally a lot of different locations in one city that causes a lot of traffic challenges. But basically, this cloud, I'm looking at this as a vehicular cloud. There's actually a real term called vehicular cloud that's kind of a grouping of the data within a transportation system that's going to be used. There's the edge gateway cloud, where we actually have the gathering of data and potentially the edge processing of data. We have the data analytics cloud, where we have the storage of data, including this additional environmental data. So you've got telemetry coming from the systems, the car systems or the cell phone applications or the other types of IoT devices. And then we have other supporting information all kept in this data cloud. And that cloud, based on location, may have to be carefully considered for geo-boundaries. In the case of this particular project, there are 50-something districts in the city of Tokyo, and a taxi driver is not allowed to go across certain lines because of their rules and all of that other stuff. But basically what we found is that in this environment, there were exceptions to those rules, and they're looking at putting the processing into the algorithms to actually support that particular use case. And of course, the last area is looking at the user interface. I'm wearing an analog watch. When I travel, I do that because smartwatches tend to run out of power. But there's also other aspects for that. But when we look at things like this and healthcare and others, there may be smartwatches that are also gathering telemetry data on your location. So maybe your app works with your smartwatch to actually share that information back for the algorithms, for the training algorithms and the inference algorithms that are used. So this is one case that we just completed the POC on, and it was a very successful project where we did learn that there's a combination of what the IT team needs to do to support these types of workloads and what the use cases are, but it also is important for looking at how do we handle the data and the data provenance so we make sure that the data does not transit particular geographic boundaries. The next use case is on monitoring and control from the edge. So you'll notice that I've shown some similar diagrams here. This is what I kind of call the cloud of clouds. Specific clouds for specific uses that may have specific governance, specific regulatory compliance. So we have an individual, I'm going to sit down as I walk through this because it'll be a little easier to do the animation. We have an elevator door at a particular facility. It could be a hospital, and there's a camera, and there might be some RFID or some other badge ways of notifying or identifying individuals for access. That could include doctors, it can include patients, it can include other staff. And the idea is somebody walks up to this elevator, the camera looks at this person and references a set of data of known individuals. And there is AI in here, so it's not just having the fact that, hey, I recognize this person, but what happens if they change, the clothing, or they're wearing a hat or not wearing a hat? You guys all football fans? Not American, I mean World Cup. Yeah. I used to be a soccer player. I played defense for a while. There's a guy named Messi, from the Qatari team. So how many different pictures and facial differences do you see with this individual? Sometimes he's wearing a full beard, sometimes a partial beard, sometimes it's shaven, sometimes it's shaven off. Do we want to keep a picture of every single potential view of that individual? No, because that's very hard to do. So we use analytics to actually think about this and identify certain variations. They use technologies to look at the distance between the eyes and the nose and the ears and all of that. But there are cases of individuals in the world that may have somebody that's a doppelganger. They look exactly like that person. How do you protect against that? You may or may not be able to do that. That's why in a lot of these systems, they're not just using facial recognition. They may have some other identification. I understand now that there are airports around the world that are looking at using this to streamline the process of going through security. And anyone who's gone through security in certain countries and cities will recognize that there's a big difference between how one group may handle security and another group may handle security. Some of the best airports, yeah.
Actually, if you fly home, there's a good chance that you will go to gates at Schiphol that do just that.
Yep. And now they're also talking about doing these query systems, which is making me a little bit more concerned of saying, hey, they ask you questions and they try to do a lie detector test, so to speak, to see are you potentially a risk or not a risk. And so these are all the things that we have to deal with, and there are going to be a lot of challenges as we go forward. Hopefully those challenges are resolved, because if they're not, it'll be like when Ted Kennedy, one of the former senators of the US, he actually was blocked from traveling for whatever, he couldn't find out why. He goes, well, I'm a senator, what do you mean I can't fly, So how do we do things for the good, for everyone, not just politicians, but also the average person? In this particular case, though, we can identify, here's one individual, it looks identical, so we know this person is the right person. We can open the elevator doors, let the person go in and go to the particular floor. Maybe there's some additional information to recognize that, hey, they're only authorized to go to specific floors. But if I were to zoom in on this picture, you'll notice that there are several images of this person with different hairstyle, with different clothing. I think there might be one with glasses. And so again, it's not just about having pictures and saying, oh, it's a match. It's also this additional analytics to understand, is the person who they say they are, and how do we ensure avoidance of risk of letting somebody who shouldn't be into a particular area from getting there. The other area is something that I'm very familiar with. This is a case of, for example, a diabetic. Diabetic has an insulin pump. They might have a continuous glucose tester to identify, what are their sugar levels, and they might also have a calibration tester. So here, the pump is the top with the little circle attached to a wire. The bottom left is actually a calibration glucose tester, and on the right, it might be a particular device. It kind of looks more like a ring on here, my apologies, but this is what the device looks like. But it attaches to your body to check every 5 minutes, what is your sugar level. And so this actually gives a reading on a specific area to ensure that this patient gets enough insulin and not too much insulin during the course of the day. And then this information, all these devices are Bluetooth based. They're not a full IoT system because it's not a full closed loop, but it's getting to that point. And in this particular case, data is uploaded to a cell phone or a smartwatch, which is then connected to a cloud, which actually has the data and analytics. So we've got the storage of the data, the telemetry, we've got some analytics and AI, but we also have maybe reference information like I've shown in the other diagrams, and we have somebody who's the healthcare provider who needs to actually look at this data and provide information, talk back with the patient and say, hey, your sugar's been high for a long time, we recommend you do this, we need closer monitoring and so on. But by itself, although this is good, there are other things to think about. What about adding on other devices? Is the patient overweight? Does the patient have high blood pressure? Is the person diabetic? Well, maybe the prescriptive care says, hey, we need to lose weight, or we need to be careful about what you're consuming and all of that stuff. These can all be used together. And then there are the correlation engines that are used to actually look at data, new data, to figure out what is the recommended next steps in this particular scenario. So this is actually one of the ways that healthcare is looking at proactive healthcare to reduce risk. There are even capsules that they have now that you can swallow that has, I don't know if it's RFID or if it's some other mechanism, but they're very small and they can actually monitor your digestive system to give additional information that would require intrusive mechanisms. It might require some, well, I won't go into the details. They're not fun details. So AI data flows. Where do we see a cloud fit with AI, which is being used to drive IoT? There's cloud for edge components, where we have the sensors and the actuators. We might have the edge gateways and analytics, which I'm showing to the right of this, because in some cases, it may bridge or overlap with the other cloud. I'm showing here 2 cloud figures, but there may be multiple clouds within those cloud environments. So this is kind of a build out of what that AI workload looks like, specifically for deep learning. Machine learning, humans write the rules. Deep learning, the machine has some starting rules, and then it learns and writes new rules. And so I see this as having clouds for the edge, clouds for the data storage, and clouds for the accelerators working together. Again, I do think it's a cloud of clouds where you have specialized clouds for specific applications. And another area is looking for a platform for AI as a service. You might have a set of modules that can be used to build a model for analysis. We have telemetry data, we have reference data, and we have, on the far right, a set of accelerators to actually run the specialized math for that. And of course, an interface so you can interface with other types of applications that work with that environment. So I'm in the tail run. There's a few more slides here. I wanted to talk about some of the new hardware and software elements for the cloud. So in the work that I've been doing with IoT and AI and blockchain, we're seeing that there are new storage technologies, there's new networking technologies. In some of these cases, we're increasing, for example, on networking, bandwidth for both wired and wireless. But I remember in the old days when people were programming in assembly and C and trying to make the smallest code possible to do what you needed to do. Sometimes you get what's called obfuscated coding, where you can't always read everything that you see, you know it's doing the right thing. But what's happened over the years is, as systems have gotten faster, and as you have more capabilities for storing larger amounts of data, people don't always write for code size and efficiency as they used to, unless they're dealing with, for example, the space program. That's one area where you can't just add more systems. So these are some of the technologies I see on storage and networking. On the compute and memory, GPUs have become more and more prevalent, not just for desktop, but also for AI and for certain types of math. The one thing that's interesting is, you hear the comment of, is a GPU better than a TPU? TPU's focused on tensor processing. So basically, you can do the AI workloads directly without all the additional graphics. I do see a value in the GPUs because doctors and other people may need to have a desktop interface to access the data and the reporting in close proximity where the analytics are, so you can minimize the time for access. There's newer technologies around memory that I've listed up there, but the big thing is, today we're seeing a massive change in how we look at hardware and these software-defined technologies on top, so we can be more agnostic in our programming and be able to use different types of underlying processors. I mentioned a little earlier how some companies are moving to multiple different types of processors. ESX is now running on ARM processors, and that came out of their early research on virtualization for cell phones. Unfortunately, Apple wasn't very big on running iOS on non-Apple devices. Other vendors, same thing. But they took that technology and then they applied it to Raspberry Pis. I saw some great demos last week around that, and very exciting. But there are a number of things that I listed here, software-defined in a number of different areas. And then on the far right, this concept of functions as a service, or function as a service. The telco industries are very big on this. How do we reduce the risk within our central offices and our core telco data centers? And that's what they're trying to do, is do software defined in this area, so they didn't have to use very expensive proprietary systems. Actually, I'll give you one example. In many cases in the telco industry, they have to have redundancy. And the redundancy is not on the order of dollars or hundreds or thousands of dollars. It's on the order of tens of thousands of dollars or tens of thousands of euros or even millions in that case. Evolution of cloud roles, really important, as I said before, to think about IT focusing on protecting the environment, and OT looking at protecting revenue generation or the things that make a company successful, or a business or a particular organization successful. The other thing I wanted to show you, I'll do a quick build out, is an example of one other technology that VMware is working on with a number of other partners, including IoT areas. They have this technology called Pulse IoT. They have, so you see here where it says L, this is called a little IoT agent that actually is used to manage some of the edge devices. And what we have is a set of devices. We have these edge intelligent gateways. We might have micro DCs or a core data center at a particular location. Think of a university, lots of buildings. So we might have these two areas, the edge gateways and the things in each building, and then we would have the core maybe at a particular campus location or several campus locations, but the data center might be in the cloud. And as we go forward, this particular technology has these Pulse IoT technologies to do the management of the stack. You can see through the arrows of what the different combinations of these 4 sections would be covered, and that's going to be based on your environment. I do see cloud providers moving forward and maybe adopting technology like this to actually help customers deal with IoT and managing it from all the way through. I think I just have 2 more slides. So do a quick build out here. All of the things that I've listed here, increased AI workloads in the cloud, looking at support for industrial IoT, extensions to support workloads that are actually run at the edge that may not have the same compute power as at the core. We have specialized clouds for mission critical workloads. We also have been seeing that accelerators are becoming more and more important for companies that are dealing with AI and IoT, to the point that their preference for their workloads is the accelerator, not the actual CPUs, traditional CPUs. Also, higher speed memories and low latency between the actual memory and the actual accelerators to increase the, to shorten the compute time and be more successful in the outcomes that they have. And then the final area is on looking at IoT, looking at how that generates a lot of data and how it can consume the resources. Just because we have more bandwidth, we have to be efficient in using it, or we'll run into the same situations we've had previously. This here is a quick build out of conceptual architecture that I've been working on within my family of companies on new technologies for compute, storage, networking, as I mentioned before, but now introducing accelerators and intelligent as well as embedded gateways. Embedded gateways have CPU, intelligent gateways have graphics processors or other types of accelerators. And then we see this cloud of clouds. We got an example of a security camera that's actually sending data to an edge device cloud that is basically a embedded gateway, for example. And in that case, it would then use that as the gathering point and share it with the other data to do the processing, to do the analytics, to do the reference information to build the inference engines. And of course, we need to have governance and compliance across all of these areas. Now, so the last thing I wanted to leave with you are a couple of things that I think are very important. As technology has been changing, we've seen converged infrastructure. But what is becoming more important is this concept of declarative infrastructure, where you could plug and play different devices. There's a company called Liquid that has a PCI gateway device with a chassis where you can have different types of PCI devices presented to a physical or virtual machine with full security boundaries around that access. We also see secure distributed ledger for data protection. These are some of the things that I would recommend you taking a look at because they're becoming more and more prevalent, more and more important, and more enterprises are adopting that. And then looking at how cloud orchestration models, how do you actually deal with deployments and management and ensuring that all the pieces work well together, given there are more and more pieces that are coming into play as a system. And the last area I wanted to leave with was thinking from your perspective. I led with this in the beginning of how do we use this for good? How do we use this new ability to have AI and IoT that could be used for spying, so to speak? You know, my Nest might know when I'm home, but how can we use it for the betterment of our society and individuals? And I really would like you to think about this, the positives and the negatives. In anything we do, there's a potential for both. But I want you to think about automation and how that fits in with AI, because the automation, if it's not programmed right, it's garbage in, garbage out, and we might have some very negative outcomes from that. And so I think with that, I'll close out on that. And I'm not sure if we have time for questions, but if not, we can do it afterwards. But I want to thank you guys for having me coming out. I hope this helped educate and give you some inspiration on some of the ideas around some of the new technologies, and also thinking about how do we work together to actually improve not just the technology space and the things that we do daily, but also our society and our environment. Cool. Thank you. Okay. Thank you. Thank you.
Thank you. I think we have some time for one or two quick questions. Any questions?
Yeah.
Please. Use the microphone. Yeah, but
we want to get on the recording, I think they said. Yeah.
Hi.
Yep.
Thank you for the peek into the future, and it's exciting. But what I would like to know your opinion, do we do enough to prevent any, how do you say that? the security-wise that we prevent. For instance, we did not know that they could use airplanes to bomb a building. What are we getting here, and what is your opinion about security-wise?
Well, I'm a believer of security first in everything that you do, because trying and re-architect things are challenging. But in this particular case, there's the social engineering aspects, and there's also the concept maybe of remote control of the planes. So if a terrorist situation were to happen, could you prevent the plane from crashing into something? But the problem is, it could also be used for the negative, not just the positive. You may not be able to, you may be able to fix some situations, but what if you have somebody like a drone operator who's got a bad intent, who's actually the person who's trying to control that? I think it's something that I flew, so there were a couple of weeks where we couldn't fly. I actually was in Germany. I flew to Germany 3 weeks after the September 11th attacks. And what I found was, yes, there's increased security, but being a frequent traveler, I do know that there's a lot of visuals that make it seem like it's safer, but knowing that if I do certain things, it may not raise a red flag, but if I do other things like change my flight at the very last minute, most likely I'll get, you know, a security scan. I'm not quite sure that we have done everything we can do to solve those types of problems, because it's a mix, I think, more on the social side, and how do you actually identify individuals without compromising your rights or your ability to be misjudged. We don't want people to be misjudged, but at the same time, how do we protect it from happening? That's something I think is still evolving, and I think it's not quite there because there are decisions that are being made that visually may look good to a majority of people, but those of us in the tech industry or who do a lot of travel recognize that, hey, you know, this is visually appealing to the masses, but I keep going through my mind of, you know, I hope some of the bad people aren't thinking, you know, the ideas that I see as being the problem areas. So, yeah.
Okay.
Thank you.
Any comment? Okay, thanks.
I'll be around all day. More than happy to talk some more.